All right, this is an example calculation for the distance between two locations anywhere on Earth. So I got the Word document here, and this is actually my example. So yours is kind of blank there except for the equations. And I got the calculator open here, and I don't need any of that that's on there, so I'm going to get that away. But here you see Anchorage and Seoul. So first thing you have to do is actually check out their coordinates. So I'm going to go to Anchorage, 61, 149 north and west. 61, 149. Well, I guess 149 is around to 150. I was pretty close to that. And then here's the 61. By the way, I will show you soon here that to make it more accurate. This doesn't look like very high accuracy because I only have 2 or 3 significant figures, but that's also because I get away with it because the two cities are very far away from each other. And then, of course, I have to look up Seoul. So here we go. Let's see, there's Seoul, 37 north, 126, or actually 127 east. And there it is, 127 east and 37 and a half north. And then here are the calculations. And I'm not going to show it for this one here. It's already done, but I will show it for another example in a minute or so. I come up with 3,800 miles. Notice because I only use 2 sig fig here, I also should only give 2 sig fig at the end, 3,800 miles. I know it already says the 3760 here, but let's check that out. So I'm going to go to the Great Distance Calculator, and maybe this is the one. Yes, it is. So I had, what was it again, 30, I have to push this to the side so I can actually see it. Let's see, so Anchorage, I had 61 north, and then the others really don't matter that much, and then 150 west, and let's put a 00 there. And then for Seoul I had 37 here, and I had half a degree, which means 30 minutes. And again, the seconds here in the back here, they really don't matter. And then here I have 127, and if I really want to, I put a 0 there. But this one is in the east, so I put an E there, and I'm going to scroll down. And and now I should calculate, let's see. And it comes out to 6,069 kilometers. Oh, and I would have to do 6,069 kilometers divided by 1.6 or 1.609 from kilometers to miles, 3,771, 3,780, and I compare that to the 3,800 here. Yeah, that's pretty close. Another way of doing it is to go to Google Maps. So here we go. And then I don't see much here, so I'm going to make this a little bigger. There we go. And let's see. Did that earlier, and let's see if I can do that again. Distance, Anchorage, Seoul. There we go. Hit enter, and there we go. Okay, I guess I could zoom in a little bit more. There we go. And then let's see if this works. Zoom in still a little bit more. So when I right click here, it says measure distance. So I click on here and I click on here, and it says measure distance. As I said, I actually did that before and it actually worked. So here we go, measure distance, click here, and why doesn't it show it? I guarantee I did that earlier. This had clear measurement. I don't even have a measurement. So measure distance from here, drag to change, click to remove. There. And there, finally, gosh, and here it is, 3,776 miles. Okay, that was my first example. Now I'm going to actually show you how to do the calculations using the new example. All right, I'm going to start over with my Google Maps here. I only need it later. And my new example is going to be for Berlin. So I'm going to have 5231 north, 1324 east. And so I'm going to go to my sheet here, change this one here to Berlin, and I just said 52 2, 31. I don't need the seconds there. And here I'm going to have 1324. And that is actually east. And I'm going to make my anchorage one, I'm sorry, my sol ones a little bit more accurate. So this one is going to be 3733. And this one is going to be 126.59. And yeah, both of them are east. Okay, now I'm going to compute these here to radians. So over here, I'm going to go 52 plus 31 divided by 60. Enter. And then I multiply by pi, and I divide by 180. That's the conversion from degrees to radians, and I come up with 0.91965. Oh, rounded 6 here. It's because I have 4 sig fig here, so I might as well use 4 sig fig over here. Then I'm going to do the same thing with the other one, with the 1324 east. So I'm going to go here. Plus 24 divided by 60, or I know that 13.4, there we go, 13.4, and then I'm going to do this, second entry, that's nice on the graphing calculator, times pi divided by 180, and I'm going to come up with 0.2339, and I'm going to pause this one here so you don't have to watch me do this over and over again. I'm going to calculate these other two. All right, I'm back, so that way I could just type here. So this one here is 37.55, then to radians times pi divided by 180, so that's going to come out to 0.6554. And the other one here, 126.98 and so on, and then I still have to hit enter. So this is going to be 2.216 again. Let's give it one more here, round it 3. Okay, so I got the coordinates in radians. Now I need to subtract them because it's about the difference between them. And in my case, I don't have to pay attention to that goes from one hemisphere to the other one because both of them are in the northern hemisphere and both of them are in the eastern hemisphere. So I just need to subtract the numbers from each other. If that was not the case, if I had one in the east and one in the west, well, then I would have to pay attention and actually have to kind of like subtract the negative from one or the other. Okay, so I'm going to do these here, latitude, 0.9166 minus 0.6554. There we go. And then I'm going to do the other one, 2.2163 minus 0.2339, and you notice that I subtracted them in a different way so that I get positive numbers for both. You will actually see that it won't matter if I have a positive or a negative number here. So let's see. This one here is the 0.2612. And this one here is going to be the 1.9824. Sure, it's 5 sig fig, a little bit more accurate than I needed to, but that's okay. Okay, now comes the big part. Now I actually have to use the Haverside formula, this one here, and do that on my graphing calculator. I'm going to clear this. I'm going to go to mode and check that I'm in radians. I'm not, so I'm going to go over here to radians. There we go. Go back to the home screen. And now I'm going to do this entire formula. So I'm going to open a parentheses. We'll tell you in a moment why. So sine the difference in latitude, which is the 0.2612 divided by 2. Close the parentheses. That's for the sine. Close the parentheses again. But here's why I have that extra parentheses there, because I need to put the square there. And I didn't know if I left that out, if it would do it correctly. So plus cosine of the latitude of the first. So 0.9166 parentheses times cosine of the second latitude 0.6554, yep, parentheses, times, so again this sine would have to be squared, so parentheses sine, the difference is the 1.9824, so this one down here, delta longitude, there we go, 24, divide by 2, whoops, don't make a mistake, huh? Divide by 2, close the parentheses for the sine, close the parentheses so I can put a square in the back. There we go, because it says so, square right there. Enter, I come up with something. I cannot really judge how good that is because it's only an intermediate step. So my intermediate step is going to come out to 0.3547 rounded. Okay. Now the shortest arc length, C, it's this one here. So I actually don't know why I have this listed twice. Okay. Both of them are the same. So I'm going to do 2 times the inverse tangent of the square root, let's see, square root of A, my answer. In fact, I'm just going to use my answer, second answer. There we go. Close the parentheses. That's actually the numerator. Now I'm going to do the denominator. So divide by the square root of 1 minus A, which again is my answer from the previous one. Close the parentheses for that square root. And at the same time, that's also the denominator. Close the parentheses for the inverse tangent. Hit enter. And again, I cannot judge that because it's still an intermediate result of 1.2759. Sure. A little bit of an overkill. And now that one would have to be multiplied by the radius of 3,958 miles, which I looked up. You can look that up. Close to 4,000 miles or 6,400 kilometers. That comes out to 5,050 miles for sig fig. You know, the last one rounds to a 0 anyway. And now I have to look that up, Berlin to Seoul. So I'm going to go, here is one of them. And let's see, the second one I believe can stick there. Well, almost. 33, I just looked it up, 126.59 here for Seoul. And for Berlin, that's 52.31. Again, the other one actually here doesn't really matter. Because that would be just way too accurate. And then this one here is, I don't know if I need a 0 in the front, I'll just put one there. 13.24. And again, this one really doesn't matter, but I do need an east right there for Berlin. And then I hit enter, and it computes 8,128 kilometers. So 8,128 kilometers divided by 1.609. Enter 5,052 miles. Of course, that, yeah, it's probably me rounding in somewhere. After all, the Great Circle calculator here uses the exact same algebra that I used. Of course, it is the Haverside Formula. See it on a map. There it is. Berlin to Seoul. I think we can see that. Yep, there we go. And I can also put it on Google Maps. I hope that's going to be a little bit more slick than the last time. I tried it this afternoon and it worked just fine. And then it was giving me some problems here. There we go. Okay, and now I'm going to click on this one here, measure distance. Click on map to trace a path you want to measure. So here and here. And that is 5,040, oops, I think I'm a little bit off, 5,040 miles. So that works out just nicely. So 5,040 or 5,052 miles, depending. And now it's your turn for two hopefully completely different locations anywhere in the world.